In this video, I'm going to discuss Modbus function number 2, which is a function where you can actually read discrete input values connected to a microcontroller. So if I can quickly go to this Proteus design, you will see that these inputs here, which is actually just ones or zeros, highs or lows, is connected to from PC1 up to PC4. This is where it's connected. And the way it's done in this specific case, if I can just recall quickly, a discrete input is normally running from one in the start, which is normally in our case I will start at address maybe 100. If you've got more than 100, then you can start at address 1000. So, but in our case we're going to start at address 100, and basically that means that this input here is actually address 100, and that will be 101, and that will be 102 and 103, etc. So what I've done in the slave microcontroller is I've set up port C to be an input pin, or input port rather. I've also set up this input array by the name of this input, of course. And I've said, let's place this input, which is shifted one position to the right. And why did I shift it one position to the right? Because I'm also making use of ADC 0 here, as you can see. So let me just undo that. So I'm not interested in what's happening at PC 0. I'm actually interested in what's happening from PC 1. And this is why I'm reading the whole port and then just moving it one position to the right. Inside the port, this specific bit sitting here, which is actually which will become a bit address number 100, will be shifted to the 0 bit position inside the port. So yeah, this is where I have stored it. In this input element number 0, and then I just said let's add that with this value, which means we're just getting rid of the upper, well, let's call it the upper 12 bits. I'm only interested at this stage at the lower 4 bits because I'm only reading, as you can see, I'm only reading 4 bits. But of course you can quite easily make this more if you want to. This inputs is in any case, if you can see where I've defined it, it's an integer, so it can actually store in one location. There can be stored 16 different addresses or 16 different inputs then. Good, so let's go to the master microcontroller. As you can see here, I've got a function here which is basically gonna it needs the argument, and in this case I'm gonna from the master microcontroller I want to speak to number 2 slave microcontroller, and I've placed an address there which is 100 because I want to basically read the status of these discrete inputs of the switches, or the highs or zeros. That's what I want to read, but I want to read by starting at this specific address. If I go to the function itself, let's go to the function itself. Here it is. Just like before, that is address number 2 now. That's the slave address rather, and this is the address which is 100. We are going to subtract 1 because Modbus wants to send 1 less, so I'm going to actually send 99 if I want to read address 100, of course. So in this array here, we will set up the slave address, function number 2, that will give the high start address. In this case it's going to be 0 zeros in any case, but yeah, I'm just leaving it as it is for now. And the low start address in this case will definitely be the 100 minus the 1, which is 99. And then here I'm saying I want to read 16. This 0010 is actually, I want to read 16 inputs. That's what I want to do. All 16, although I know I've only got 4, so I'm only going to be able to receive back 4 and only to display back 4 in this specific example. So this data will now be sent. We're making use of this sending function. We've looked at this before. All these bits will be sent one at a time. There will be in total a 6 elements that will be sent, 6 bytes that will be sent to the slave, and only the one with address 02 will be acting on the slave address number 2, of course. So let's have a look at what's happening here. As I've said specifically with a previous, I think it was function number 15. I think it was 15. The data will be received. This receive interrupt vector will be activated, and we will basically start by loading these values in this as a receive array, starting with a value of 0 there, element 0 then, and in here we will receive a 2. So this is why it will check in here, but until the whole message was received, nothing will really happen. So this will increment to a 1, and the next one will be loaded, and to a 2, and the next one will be loaded, etc. So at the end of the day, in the receive array, you will actually sit with exactly what you see here. Exactly what was sent will be, this is now, look, I'm now referring to the master microcontroller. So what you will receive, what you see here, will actually be sitting inside the slave slave receive array. That's where you will find all those datas. So we've seen what will happen is we are sending number 2, so RX array will definitely not be this one, because that element number 1 here, it's looking for 15. Here it's looking for 1, and here it sees 2, and that's the one I'm interested in, as well as 6, because my counter will be at 6 at that stage. Now again, the input address is actually, you can get that input address from receive array element number 2, which is here, and by combining that with number 3, you are actually going to get a value of 99, which is then incremented, becomes 100, and that's really the one I'm looking for, address number, starting at address number 100. The receive counter will again be reset to 0. We just, now this is setting up the response from function number 2. So the response will actually, again, element 0, it will load that with 02 function, or sorry, not function, element number 1 will be loaded with 2, which is function number 2. It's going to tell the master microcontroller there will be 2 bytes that will be sent. As you can see here, like before, I've created a pointer. So I've loaded that pointer with the address of this inputs, and we've seen when I've started with this that this inputs the element number 0. This is where the 16 bit addresses basically sit in this specific case. So if input address is 100, that means it's going to be 100 here, minus 100 gives 0. So I'm actually loading the address of this input's element number 0, as I've stated before. This is what I have loaded, as you can see here at the bottom. I have loaded into this input 0. This is where my 4 input statuses will be basically be placed in element number 0. So here you must just be very careful, because in this specific case I'm saying transmit back into element number 3, place in element number 3 the value pointed to by DI. Now DI is actually pointing to 16 bits, in other words, because it's an integer, and the low byte will be placed in here. And this is why I say this is actually from register number 100 to 107. And if we move the value pointed to, because now we're looking at the upper nibble of the integer, sitting inside element number 0 here. So what you have there is basically the upper nibble, but in our case we haven't got register 108 to 115 in any case. No, we haven't got that, but I'm just showing you it can be done. And then, just like before, we need to start transmitting this specific array. There will be 5 bytes that will be sent. This is again waiting for the transmitter to make sure there's nothing inside the data register. It will start by sending the first one, which is element 0, then element 1, 2, 3, and 4. So there will be in total 5 bytes that will be sent. And I'm just showing on port B again, it is function number 2, which is now responded. So, and what I'm also doing in the master microcontroller is I am continuously, basically, this is sitting in the while one loop, so I'm continuously reading these values. Yeah, and if I look at, let me just go up and look at what if I've received 5, yeah, here it is. If I've received 5 bytes from slave number 2, slave micro number 2, and this element number 1 is a value of 2, that means this is what is received back from slave number 2. This is the master micro program. This one I'm sitting at, looking at this stage. And then all I'm doing is I'm just displaying on port B again what is sitting on the receive array number 3. So we know by now at this stage number 3 contains from address 100 up to address 107, although I'm actually only looking at 100, 101, 102 and 103. So let's have a look at the operation of this thing. I've already built everything, and let me start here. And as you can see, the master micro sent the request function number 2. Function number 2 collected the value from addresses 100 to 103 and transmitted it back, and the master microcontroller then displays it on port B. So if you look at this, if you really look at this, look here, this is the least significant bit. This is 1001, and here it is displayed as 1001. If I make this bit a high by opening the switch again, it's going to be 1101, and there you go. So first of all, this micro, the master is continuously asking, and the slave is continuously responding. But as you can see, 1011, and it reflects here 1011. So the master knows exactly what's happening with discrete inputs on the slave 2 that we have here. And this is the functioning of Modbus function number 2, where we can also read discrete input values. So we've got a whole combination of different functions which can actually do whatever needs to be done in any master slave Modbus configuration. Thank you.